Thank you, everyone, and thank you very much for the honorable mention. I really appreciate to be here. My name is Shu, and I'll be presenting this paper, Worldwide Recipe. And I'm sure all of you are looking forward to lunch, and I'll make you hungrier by talking about food for the next 9 minutes. So why did we focus on food? Because we think that food really represents the difficulty, the complexity, and the richness of culture, and how it's different from other characteristics what we talk about when we talk about biases in AI models is, for race or ethnicity, gender, age, we have some kind of a ground truth or maybe your identity. However, for food, it's really complex in the sense that it's a many-to-many mapping. You have lots of regions with slight varying different ways of cooking the food, different recipes. So many people associate with the same kind of dishes. And also there are many dishes, many regions. So it's a very complex problem space. And we want to draw the attention of how AI models can bias this representation, and that can be harmful in many different ways. For instance, if you go out into Athens and ask ChatGPT what's a nice authentic Greek food for lunch, then you might have some images. And I tried it yesterday. I can't verify it for myself because I'm not a local, but you might just believe it. And let's say you go to another country which is slightly less represented, and then you might get some results which you might believe again. But then that's really creates a perpetuous kind of reinforcement in these biases, and then you upload it to the internet, and then more people, so it creates a cycle. And we think that we need to address this issue. And this recipe is talking about the overall framework that we came up with when we are trying to address and quantify these biases. So we have 14 authors, and a lot of this is the most rich collaboration I had, and they are from Algiers, Nigeria, Kenya, Cameroon, USA, South Africa, Egypt, and we have a lot of, sorry, if I forgot some countries, Russia, Japan, it's me. And they are studying in all over the world, UK, France, Germany, Canada, etc., etc. I also like to highlight another issue here, that a lot of my collaborators couldn't make it to this conference because of the visa issues, and that really creates another systemic bias here. It'll be so rich and meaningful to have participation and collaboration, communication about these very difficult problems. However, we don't have this opportunity, so that's another big issue here. The problem is, how do we evaluate these model biases? Because, like I say, there's no real ground truth that we can just, or it's very difficult to find the ground truth. And we came to the conclusion that we really need to involve participants from the community. And we have to have iterative, meaningful conversations. We need to first know what the ground truth is, if there is a ground truth, or maybe there are multiple versions of ground truths, and we need to have that communication. And then we need to evaluate the model by generating images and text from the models, and then going back to the collaborators and asking whether these are actually representative and authentic. So we can't just go to the internet and download a bunch of images and say that this is done. This is the ground truth data set. No, we have to have this communication and conversation. So I would like to talk about how we apply this worldwide recipe to our specific focus on food. So there are two separate things: worldwide recipe, which is the framework, and worldwide dishes, which is the data set that we aggregated in order to evaluate these models. So it's a participatory, community-centric framework, and for quantifiably measuring biases of AI models via culturally aware data collection and review. So you can see that community comes first, and also community comes at the very end when we are trying to evaluate the models. And how we apply to the specific focus on food is that this is an example of how dishes generated by these models look like. And at the top, this is the data set that we aggregated from the worldwide dishes. And below, you can see all these different generated AI images. And you can see that not all of them are very representative. And interestingly, DALL-E 2 is more realistic compared to DALL-E 3 when prompted naively. And I will discuss it more in detail later if I have time. So we applied this recipe in 2 big steps and 4 like small steps. But first we need to aggregate, collect this rich ground truth data by talking to the community, going out into the community, and we collected its worldwide dishes data set. Then, using this data set, we can prompt these AI models, generate images, or generate descriptions of the dishes, maybe the recipe or the ingredients used for making the dish. And then we took 2 approaches. We went back to the community collaborators and ambassadors and asked them to review the generated results. We also tried to automate the bias operationalization. Operationalization meaning quantifying and measuring these conceptual, usually immeasurable quantities, but we try to quantify and measure them. And I think it's an iterative process. It's not like you can just run a machine learning model or evaluation metric, and that's done. You have to continuously talk to the community collaborators and refine your metrics as you go along. So what did we achieve? We have a mixture of 765 dishes from 106 different regions, and we also have 131 local languages represented in our dishes, our data set. And what does the data set include? It includes the dish name, both in the English pronunciation and in the local language, and the region that it comes from, the ingredients of the dish, the time of the day eaten, the type of meal. And we also have, optionally, the users can upload, or the collaborators can upload an image of the dish, the recipe, the utensils used, etc., etc. These are some of the examples, like more visual examples to give you an idea of what our data set looks like. So we chose 2 dishes, and as you can see, the users or like the collaborators can specify the occasions at which the dish is eaten. And in the center, we think that this really represents how we envision this collaboration and communication to be like. This is a baobab tree, and it's a very important symbolization in the African continent. And the old and the young, the community comes together under this tree and has this communication. And through this communication, you exchange knowledge. So that's how we envision this evaluation of AI models and the debiasing process to look like. So what's different about the worldwide dishes? We created a data collection platform, and importantly, we really focused on mobile friendliness and 2G data access, because a lot of our collaborators are living in low connectivity regions. So we need to really make this website accessible to people. Unfortunately, in this particular project, we were only able to develop the website in English. However, in the future, we really want to explore localized languages and more accessible design. And I'll skip this one. We also try to make the experience interactive and try to gamify the experience by creating a leaderboard so that people feel really involved in this process. And we have community ambassadors from different regions, and they really helped nurture this sense of community. And we also have a Slack channel, and we have a WhatsApp group, and we can share knowledge and exchange our experiences. Now, we come to the important, and I'll have 40 seconds, so bias operationalization, which is to quantify and measure the biases. So we took 2 different approaches. So one is to involve the community ambassadors and reviewers. So once these images are generated, then they can go into the image and really evaluate whether they are accurate or well represented. And we saw that the accuracy tends to be higher. We chose 5 different African regions in particular to compare against the United States as a baseline. And we saw that there are this bias in the sense that these regions have lower accuracy when images are generated from the model. And we also saw that a lot of the time, these models produce unappetizing or inappropriate images, sometimes disturbing images. And I would really encourage you to look at the paper more in detail. There are some stereotyping behavior. So a lot of the time, we call it the frozen in time behavior, where there's like a a lot of clay pots being demonstrated, but it doesn't really represent the actual experience of the person living in these regions. And little depiction of ingredients. Sometimes on the very right, you can see that although the soup is made out of the protein of the worm, and you have to cook it, so it doesn't really come up in the image. But then in this generated image, you see like the literal depiction of worms, etc. The first one was involving the community. Sorry, I'm going over time a little bit. And the second one is bias operationalization with the automated method. And I need to skip a little bit, but we use the VQA to ask questions about the image that's generated, and then the VQA can tell us what can be the biases involved. So, for instance, you can ask about the different materials of the dishes, and if it's really skewed towards a certain stereotype, then you can evaluate it in an automated fashion. Although, again, this really involves community communication to identify what exactly can be these stereotypes. And another method we used was to look at the cosine embeddings, cosine similarity of the different embeddings using CLIP. And we came up with positive and negative descriptions of the way you describe a dish. And we saw a very high correlation of Western, or there's a Japanese dish over there, but appetizing dishes were from these regions, whereas for the model thinks or generates images which are slightly less appetizing, etc., from underrepresented regions, or very, so it is very important to keep creating, training the model and evaluating the model with more participation, more representation from different regions, not just like a naive view of the internet. And we really want to emphasize that. And we've kind of run out of time for the LLMs, so please look at the paper appendix. I spent like a week of all-nighters for it, so I would appreciate it if you look at the paper. Sometimes the LLM generates the okay one is, I'm sorry, I don't really understand this dish. However, sometimes it says that, oh, this is a fictitious dish, or this is an imaginary dish, and this is really harmful because these dishes are real-world experiences. Like, people actually eat this dish. It's a very common dish in these regions, and negating these experiences for these people are very harmful. So we would really like to express, the importance of work in this aspect. Finally, I'm very sorry, but I really want to thank all the collaborators. They really helped us gather this data set and evaluate this data set, and this work is not possible without them. So special thanks to them. And also, thank you to all the sponsors and the people, the institutions which enabled our PhDs and studies. Thank you very much.